Near the Sun, a small planet hides with big secrets, Atarad, the small and hot planet. We were deceived for years, but now space robots have uncovered strange surprises. They say they found diamonds on the hottest planet, and this is just the beginning. Atarad's insides are completely unnatural, very large and very strange. Why is it so different from the other planets? What else is Atarad hiding? Atarad, the smallest planet in our solar system, has greatly interested astronomers and space enthusiasts. Its mysterious features, which remained hidden from view for centuries, only began to reveal their secrets when space exploration advanced significantly. The journey to discover the mysterious features of Atarad began with the Mariner 10 mission, launched by National Aeronautics and Space Administration in 1973, and continued with the Messenger probe in 2004. Mariner 10 was the first spacecraft to visit Atarad, giving us our first close-up look at this elusive world. During its journeys, it captured images that revealed a terrain full of craters and strange ridges, closely resembling our moon. This mission revealed that Atarad has a rough surface full of craters, side by side with a surprisingly strong magnetic field and a core larger than expected. These discoveries challenged what scientists previously assumed about the composition of Atarad. The Messenger mission, which was launched 31 years after Mariner, took our understanding of Atarad to new levels, unlike its predecessor. Messenger was designed to enter orbit around Atarad, which allowed for a more comprehensive study of the planet. During its mission, Messenger captured nearly 200,000 revealing images of areas on Atarad that had never been seen before. One of the most astonishing discoveries made by Messenger was the presence of unusually high levels of calcium and magnesium on the dark side of Atarad. This raised questions about the processes that could lead to such concentrations. In addition, the mission found that the magnetic field of Atarad was unexpectedly strong in the northern regions, which was not anticipated compared to other planets. These discoveries led scientists to realize that the internal structure of Atarad and its formation process were completely different from what they initially believed. On most planets, like Earth, magnetic fields are generated by the movement of liquid iron in the core. However, the unique internal structure of Atarad leads to a different magnetic behavior. But what makes the surface features of Atarad stand out really? It's not just the craters and ridges, but also the harsh conditions on its surface. During the day, temperatures on Atarad can reach 436 degrees Celsius or 816 degrees Fahrenheit, which is hot enough to melt lead. At night, temperatures drop to minus 180 degrees Celsius or minus 296 degrees Fahrenheit. This extreme variation in temperature is due to Atarad's thin atmosphere, which does little to regulate or retain heat. Despite these harsh conditions, recent studies have revealed some surprising features on Atarad's surface. In 2012, Messenger data revealed evidence of volcanic activity on Atarad, including volcanic deposits from explosive eruptions. This discovery challenged the long-held belief that Atarad was geologically dead, and what's even more astonishing. In 2012, scientists announced the discovery of water ice in some of Atarad's polar craters. These permanently shadowed regions are cold enough to preserve water ice, even on a planet very close to the Sun. This discovery raised new questions about the possibility of simple forms of life existing on Atarad. Could there be extremophils, similar to those found in harsh environments on Earth, living in these icy refuges? One important mission to Atarad is Bibi Colombo, which was launched in 2018 as a joint project between the European Space Agency and the Japanese Aerospace Exploration Agency. It is scheduled to reach Atarad in 2025. This mission is expected to provide more detailed information about the surface of Atarad, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of water ice, Atarad continues to surprise us. But what we are about to discover will make you reconsider what you know. How can a planet so close to the Sun have a year shorter than its day? Oh, when we think about planets, we usually imagine that they rotate around their axis once a day and orbit the Sun over the course of a year. But Atarad breaks this pattern in an interesting way. In this small, burning world, the year is actually shorter than the day. Let's break it down. Atarad takes only 88 days to complete one orbit around the Sun. This fast journey makes a Mercurian year much shorter than our year. But here's where things get really interesting. A single day on Atarad, meaning a full rotation around its axis, takes 176 Earth days. This means that a year on Atarad is only half as long as its day. This unusual situation creates some truly strange effects. If you were standing on the surface of Atarad, you would see the Sun rise, then gradually grow larger in the sky as it moves slowly across the heavens. At a certain point, the Sun will appear to stop, then move backward for a while before resuming its original direction. This strange dance happens because Atarad's rotation can't keep up with its fast orbit. But why does Atarad rotate so slowly? Scientists believe that the reason for this is something called tidal locking. Over billions of years, the Sun's gravitational pull slowed down Atarad's rotation, but unlike Earth's moon, which has become completely tidally locked to Earth, that is, it rotates once on its axis in the same amount of time it takes to orbit the Earth, which makes it always show us the same face. Atarad is in a state known as spin-orbit resonance, 3:2, which means it rotates 3 times on its axis for every 2 orbits it makes around the Sun. This unusual day-night cycle leads to harsh surface conditions. The side facing the Sun bakes under intense heat for several months, while the night side remains in cold darkness for an equally long period. This leads to extreme temperature variations, considered among the most severe thermal changes in the solar system. Speaking of Mercury's atmosphere, or rather its absence, we should note that the thin atmosphere Mercury does have is called the exosphere. This extremely thin layer of gases is constantly being lost to space and is replenished through various processes. The solar wind, radiative decay, and even the effects of small meteoroids all contribute to maintaining the tenuous exosphere. Recent observations have revealed some surprising components in Atarad's exosphere. In 2020, researchers using data from the MESSENGER probe discovered that Atarad's exosphere contains more water vapor than previously thought. It is believed that this water vapor forms when hydrogen from the solar wind reacts with the oxygen present in the rocks on Atarad's surface. Another interesting aspect of Atarad's short year and long day is how this affects its magnetic field. Despite its small size and slow rotation, Atarad has a global magnetic field, which was a surprise to scientists when it was first discovered. Recent studies indicate that Atarad's magnetic field is generated by a unique dynamo in its liquid metallic core, which is influenced by its unusual orbital and rotational characteristics. This magnetic field, although much weaker than Earth's field, plays a vital role in protecting Atarad's surface from the harsh solar winds. Without this magnetic field, the solar winds would strip away what remains of Atarad's thin atmosphere much more quickly. Atarad's rapid orbit and slow rotation also open up some intriguing possibilities for observation. There are specific points on Atarad's surface called hot poles, where the Sun appears to stand still in the sky at certain times. These hot poles experience the highest temperatures on the planet. On the other hand, there are regions near Atarad's poles that never see sunlight at all. In these permanently shadowed areas, scientists have discovered the presence of water ice. But how does ice remain on a planet so close to the Sun? The answer lies in Atarad's unique orbit and rotation, the craters that are permanently shadowed near Atarad's poles. They never receive any direct sunlight, which keeps them extremely cold, even when temperatures rise in the nearby areas. This discovery made scientists wonder if there could be other volatile materials, like organic compounds, preserved in these cold traps. The short year and long day also affect how scientists study Atarad, since Atarad orbits the Sun quickly. Reaching it poses a challenge for spacecraft. These spacecraft need to use complex maneuvers, including several flybys around the planet Al-Zuhara and Atarad itself, to slow down enough to enter orbit around the planet. The BB Colombo mission, which is now on its way to Atarad, will use these gravity assists to gradually adjust its speed and trajectory. The spacecraft was launched in 2018, and it will not enter Atarad's orbit until 2025 after completing 9 flybys around the planets. And once it reaches orbit, BB Colombo will face another challenge related to the strange day and night cycle on Atarad. The spacecraft will need to manage exposure to extreme heat on the daytime side of Atarad, while conserving energy during the long, cold night. This delicate balance is essential for the mission's success, and it highlights the harsh conditions created by Atarad's unique cycle. Recent computer simulations have revealed new insights into how Atarad ended up with its current rotation. These models suggest that Atarad may have rotated faster in the past, but it was slowed down by gravitational effects from the Sun and the impacts of large meteoroids or comets. These studies help us understand not only the history of Atarad, but also how other planets in the solar system have evolved as scientists continue to study Atarad. New questions arise. How does the planet's core remain partially liquid despite the long nights and extreme cold? And what role does Atarad's unique orbit play in shaping its geology? These questions remind us that there are still many mysteries waiting to be discovered, even within our own solar system. The unique characteristics of Atarad challenge our understanding of planetary formation and evolution, pushing us to expand our theories and explore new possibilities. So, what other secrets might Atarad be hiding beneath its cratered surface? Atarad, the smallest planet in our solar system, contains an astonishing number of mysteries within its small frame. Despite its small size, Atarad continues to amaze scientists with its unique characteristics and the surprises it reveals. One of the most astonishing mysteries is its unexpectedly massive core. Dr. Nancy Chabot, a planetary scientist at the Applied Physics Laboratory at Johns Hopkins University, led the research. A study revealed that Mercury's core makes up about 85% of the planet's volume, which is much larger compared to Earth's core, which makes up only about 15% of our planet's volume. But why does Mercury have such a massive core? One theory suggests that Mercury may have been a much larger planet in the past, but it lost most of its outer layers due to a massive collision. At an early time in the history of the solar system, this idea, known as the hit-and-run scenario, was proposed by Dr. Eric Asfalg from the University of Arizona. According to this theory, a massive planetary body may have collided with Mercury, stripping the planet of most of its crust and mantle, leaving behind the iron-rich core that we see today. Another very mysterious secret concerns Mercury's magnetic field. Unlike Venus and Mars, which do not have global magnetic fields, Mercury produces a magnetic field that is only about 1% as strong as Earth's magnetic field. This magnetic field was first discovered by National Aeronautics and Space Administration's Messenger mission, which puzzled scientists because it was not expected that a small planet with a slow rotation could maintain a magnetic dynamo. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, led a team that discovered something even more astonishing about Mercury's magnetic field. They found that this field is not centered on the planet's core, but is offset by about 20% of Mercury's radius. This offset may be due to variations in the thickness of Mercury's crust, which affects how heat is transferred from inside the planet. But the mysteries don't stop there. In 2020, scientists announced the discovery of volatile elements on the surface of Mercury, including sulfur, potassium, and sodium. These elements usually evaporate quickly at high temperatures, so finding them on a planet so close to the Sun was unexpected. Dr. Patrick Biblowski from the Applied Physics Laboratory at Johns Hopkins University suggested that these volatile elements may have arrived on Mercury via comets or asteroids after the planet formed. One of the most exciting discoveries recently made on Mercury is the presence of water ice in the permanently shadowed craters near its poles. Dr. Nancy Chabut, whom we mentioned earlier, also participated in this research. The ice exists despite Mercury's proximity to the Sun because these craters never receive direct sunlight, which keeps their temperatures extremely low. But here lies the most fascinating part. In addition to water ice, scientists have found evidence of organic compounds in the same craters. These dark deposits may be complex carbon-based molecules, similar to those that might have played a role in the origin of life on Earth. Could Mercury, despite its harsh conditions, contain evidence about how life began in our solar system? Another highly mysterious secret is Mercury's unexpected geological activity. For years, scientists believed Mercury was a geologically dead world, but data from the Messenger mission revealed evidence of relatively recent volcanic activity. Dr. David Rothery from the Open University in the United Kingdom identified small, bright spots on Mercury's surface that appear to be volcanic craters. These features, known as hollows, suggest that Mercury may still be geologically active today. One of the most mysterious terrains on Mercury is the chaotic terrain, which is a vast area of hills and disturbed valleys near the planet's south pole. This region was first observed by the Mariner 10 mission in the 1970s, and it covers an area the size of the state of Texas. Dr. Thomas Waters from the Smithsonian Institution suggested that this terrain may have formed as a result of massive earthquakes caused by the tidal forces of the Sun. As Mercury's orbit evolved, recent studies have also revealed surprising details about Mercury's formation. Dr. Amir Khan from the University of Zurich used data from the Messenger mission to study Mercury's internal structure. And his team found that Mercury's core likely consists of a liquid outer layer and a solid inner core, similar to the structure of Earth's core. However, Mercury's inner core is relatively larger, which may explain some of the planet's unique magnetic properties. These dense mysteries that Mercury holds challenge our understanding of planetary formation and evolution, reminding us that even in our nearby cosmic neighborhood, there are still many unsolved mysteries.